So in this video we're going to continue on our previous lesson on binomial distribution. Now this video is going to focus on the expected mean and the variance. Now what is the expected mean? Now the expected mean represents the long-term average over many repetitions of the experiments. Now it is also known as the expected value. Now we know the variance to be the spread of data, or in this case your known probability. All right, now let's quickly pick a question to diffuse. Now in a binomial distribution, we have the formula for our expected mean. It is denoted as mu, alright, to be the product of n and p, alright, where n is the number of trials and p is the probability of a success. Alright, and we have our variance. Alright, we know it to be the root of our standard deviation. Alright, now standard deviation is the product of our n, p and q, where q is just the probability of a failure. Alright, also denoted as 1 minus p. Alright, so let's quickly use this info to find our mean. Alright, now from here our n is 10 and our p is 0.6, so our mean value is 10. What this simply means is that 6 is just the expected number of outcomes. Alright, given the number of trials and probability of a success. Alright, the expected mean just simply gives us a show light of the expected number of outcomes. Alright, so we can just use and also use this given information to find our variance, which is the root of npq. Alright, alright, so I want us to quickly learn how to use our Pascal triangles to find the probability of getting a certain number of outcome after flipping a coin. Alright, so let's assume that we were to flip a coin, let's see 3 times, and we want to find the probability of these individual outcomes. Let's see, probability of getting heads. Alright, number of heads. Alright, of getting 0 heads. Well, we can use our Pascal triangle to actually compute this. From our Pascal triangle we can simply write, alright, now this towers just represents the number of trials. For example, the first tower is 0, the second tower is 1, the third tower is 2, and so on and so forth. So in this case we have 3 trials, so we have to have 4 towers. Alright, now in a binomial distribution, the total number of possible trials is denoted, or is given as 2 to the power of n, where n is the number of trials. Right, the total number of possible trials in this scenario is 2 to the power of 3, which is 8. Alright, so with this given information we can now compute our probabilities of each specific outcomes easily. All right, so for this, let's quickly put down our Pascal triangle again. Pardon for deleting the previous earlier. Right, so for this, from our fourth tour, which is representing the third number of trial, or the number of trial, which is 3. All right, the first value is 1, so we have 1 over the total number, which is 8. All right, for 1, the next value is 3. All right, for 2, the next value is 3. All right, and for 3, the next value is 1. So yeah, we can use our formula for the probability distribution to actually verify this, and we'll see that we come to the same outcome, where P is just 1 over 2 and Q is also 1 over 2, and we see that we happen to arrive at the same outcome. So yeah, let's quickly let's try this for number of trials. All right, so let's write down our Pascal triangle. All right, and we have 1 4 6 4 1. Right, so the probability of getting 0 heads is just 1 over 2 to the power of 4. All right, it's 1 over 16. The next value here is 4. Right, the next value after 4 is 6. Right, the next value after 6 is 4, and the next value is, so we can check that if we add the probability of these values, if we add all together, to happen to give us a sum of 1. All right, so this just verifies what we learned earlier, that the sum of all possible probabilities is in a binomial distribution is 1. So yeah, look at this problem. If you want to do this yourself, you can simply pause the video and try it. All right, now the question says a factory produces widgets with a probability of 0.2 that a widget is defective. If 15 widgets are produced, what is the probability of finding exactly 5 defective widgets? Well, we can simply deal with this using our binomial formula. All right, and we know it to be n choose k, b to the power of k, q to the power of n minus k. All right, we know that our n is 15 in this case. Right, our k is 5. Our p is the probability of a success, which in this case is 0.2. all right, to the power of 5, and the probability of a failure, which is 1 minus p to the power of 15 minus 5, which is 10. All right, so go ahead and plug this into your calculator and you will get your value. All right, now yes, that's all for the binomial distribution, and in the next video we'll probably dive into the geometric and the Poisson's distribution.